Hello friends. Whatever we can measure, in physics we call them as physical quantities. There are two types, scalar quantity and vector quantity. Scalar quantities are those quantities which have only magnitude, and vector quantities have both magnitude and direction. And in addition, vector quantities must follow the laws of vector addition. Every body in this universe is in the state of constant motion, and every day we see different bodies undergoing different types of motion. Although nothing is at rest, but we often say that a book lying on the table is at rest. This is because the book does not change its position with respect to us. Therefore, a body is said to be at rest if it does not change its position with respect to its immediate surroundings. Similarly, a body is said to be in motion if it changes its position with respect to its immediate surrounding. Practically, we don't have any body which is at absolute rest or in absolute motion. Therefore, the rest and motion are relative terms. For instance, this person may be at rest relative to the other person, but they are both in motion relative to the person standing outside. So, rest and motion are always with respect to some frame of reference. Our earth is moving around the sun. We are in the state of motion even when we are sleeping. So, we don't have anything which is at perfect rest or in perfect motion. Distance traveled by a moving body is the length of the actual path traveled by the body. It is a scalar quantity and its SI unit is meter. While the displacement of a moving body is the shortest distance or the linear distance between the initial and the final position of the body. It is a vector quantity and its SI unit is also meter. In this diagram, A, B, C are the three places. Distance traveled by the body from A to B is 3 meter. But the displacement of the body from A to B is 3 meter towards east. So displacement will also have direction. Distance traveled by the body from A to C along the path ABC is 3 plus 4 meter, that is equals to 7 meter. But the displacement of the body from A to C is 5 meter towards northeast. You know, displacement is the shortest distance between the initial and the final position. So A is the initial position and C is the final position in this case, and the direction is towards northeast. If the body starting from A comes back to A again after traveling along the path ABCA, then the total distance traveled by the body will be 3 meter plus 4 meter plus 5 meter, that is equals to 12 meter. But the total displacement of the body along this path, that is along ABCA, will be 0 and its direction will be southwest. The displacement is 0 because the initial position of the body as well as its final position is A. So there is no linear distance between initial and the final position. Next term which help us in describing the motion is speed. Speed tells us how fast the body is moving. Speed of a moving body is the rate of change of distance with time. So its SI unit is meter per second and it is a scalar quantity. There are different types of speeds. When a body covers equal distances in equal time intervals, then the body is said to be moving with uniform speed. In the diagram, the distance between A and B, B and C, C and D are all equal to 4 meter, and the time taken to cover these distances in all the cases is equal to 2 seconds. So if you find the speed of the body from A to B, that is distance by time, which is equals to 2 meter per second, and the speed of the body from B to C is also 2 meter per second, which means the speed is constant or uniform. If a body covers unequal distances in equal time intervals or equal distances in unequal time intervals, then the body is said to be moving with variable speed. When the speed of the body is changing or variable, then the speed at a particular instant of time is called its instantaneous speed. Speedometer in vehicles measure this instantaneous speed. Again, if the speed of the body is variable or non-uniform, then the average speed is given by total distance traveled by total time taken. When a body is moving with uniform speed, then the instantaneous speed and the average speed will be equal to each other. The velocity of a moving body is the rate of change of displacement with time. Its SI unit is meter per second and it is a vector quantity. The velocity of the body changes when its magnitude or its direction changes. Like in the case of speed, there are different types of velocities: uniform velocity, non-uniform velocity, instantaneous velocity, and average velocity. When the velocity of the body increases with time, then the body will have acceleration. So acceleration is increase in velocity by time. Its SI unit is meter per second square and it is a vector quantity. In this example, as the body moves from A to B, then its velocity increases from 5 meter per second to 10 meter per second in 2 seconds. So therefore, its acceleration is increase in velocity by time, which is equals to 2.5 meter per second square. The opposite of acceleration is retardation. It is the rate of decrease in velocity with time. It is also known as deceleration or negative acceleration. When a body falls towards the earth under gravity, then the velocity of the body continuously increases with time. This increase in velocity with time due to gravity of the earth is called acceleration due to gravity. Average value of acceleration due to gravity is 9.8 meter per second square, which is measured at sea level at 45-degree latitude. The value of g or acceleration due to gravity is 9.8 meter per second square, means that as the body falls towards the earth, then after every second its velocity increases by 9.8 meter per second. So similarly, when a body is thrown vertically upwards, then due to gravity its velocity decreases by 9.8 meter per second after every 1 second. The motion in one dimension can also be represented graphically. For this, we require different types of graphs. One such graph is the displacement time graph or ST graph. Displacement denoted by S and time denoted by T. With the help of this graph, we can represent different types of motion. So if you look at this diagram, here we have an observer and a body. This body is at rest with respect to the observer, and the body is 2 meters away from the observer. So as the time passes, the body is not changing the position. So therefore, if we tabulate the values of time and the displacement of the body from the observer, then it will look like this. As the time increases from 0, then the displacement is not changing. It is remaining 2 meters only. So if we plot a graph for such kind of a body, then it will look like this. So in a displacement time graph, we need to remember that we always plot displacement along the vertical axis and the time along the horizontal axis. Displacement is measured in meter, SI unit is meter, and the SI unit of time is second. So from this table, if we plot the graph, then it will look like this. First point to be plotted is 0 and 2, 0, 2. That means when the time is 0, the displacement is 2 meters. So this is the first point. And the second one is when the time is 1 second, the displacement is 2 meters again. So in 1 second, displacement is 2 meters. So similarly, when the time is 2, displacement is 2. So we can continue like this. So if we join all these points, then we get a straight line. This is a straight line parallel to the time axis. So if we have a body at rest, then the displacement time graph of a body which is at rest will be a line, straight line parallel to the time axis. So from the displacement time graph, we can calculate basically two important things. The first one is the displacement of the body at a particular instant of time. Like for example, if we want to know from the graph what is the displacement of the body after 2 seconds, then you can do it like this. Displacement of the body after 2 seconds is 2 meter. What is the displacement of the time in, let's say, 2.5 seconds? If you want to find out, then from here you have to drop a perpendicular like this on the line. Then from here it goes this side. That means in 2.5 seconds also displacement is 2 meter. So first thing, from the displacement time graph, we can calculate the displacement of the body at an instant. And the second important thing that we can calculate from the displacement time graph is the velocity of the body. If we find the slope of this graph, the slope of the graph will give us the velocity. Slope of the displacement time graph will give us the velocity of the body. So here, if we calculate the slope of displacement time graph, then this will give us the velocity of the body. So here this line is parallel to the time axis. It is not inclined to the time axis, it is parallel to the time axis. Therefore, its slope will be 0, which means velocity of the body is also 0. Because we know this is a graph for the body which is at rest. So its velocity obviously will be 0. In the second case, we have taken a body which is moving with uniform velocity. That is, its displacement is increasing by the same amount in equal time interval. For such kind of motion, the displacement time graph will be a straight line inclined to the time axis. So here we have taken two situations. In the first case, when the time is 0, displacement is also 0. As the time increases, displacement also increases by the same amount, by equal amount. In the second case, when the time is 0, displacement is not 0. It is 10 meter away from the body. And as the time, it is 10 meter away from the observer. And as the time increases, displacement also increases by equal amount. Now let us try to draw the displacement time graph for this kind of motion. Displacement is plotted along the vertical axis, time is plotted along the horizontal axis. Now the first point that is to be plotted is when the time is 0, displacement is 0. That means when the time, this side we have time, when the time is 0, displacement is also 0. So the first point will lie here. Second one is when the time is 1, displacement is 10 meter. When the time is 1, displacement is 10 meter. Then the point will be somewhere here. Fourth one is when the time is 3 seconds, then displacement is 30 meter. That means the body has been displaced 30 meter away from the observer. So this is the fourth point. Now if we join all these points, then as expected we get a straight line, and in this case this straight line is passing through the origin. Now from the displacement time graph, I have already told you we can calculate two important things. First one is the displacement of the body at any instant of time. Now let's say if we want to know what is the displacement of the body after 2.5 seconds. Then in order to know the displacement of the body after 2.5 seconds, from the graph we can drop a line like this. We can draw a line like this from 2.5 on the graph line, and again from this point we drop perpendicular on the displacement axis. So that means after 2.5 seconds, this is the displacement of the body. this is exactly in between 20 and 30, which means this value is 25 meter. That means after 2.5 seconds, the displacement of the body will be 25 meter. So likewise, you can also calculate the displacement after different instant of time. The second thing we can calculate is the velocity of the body. So in order to calculate the velocity of the body, in this we have to find the slope of this graph line, slope of the displacement time graph. So in order to find the slope or the gradient on this graph line, we can take any 2 points. Let's say if I take this point and this point. Then with the help of these 2 points, you complete a right angle triangle like this. So let's say this is A, this is B, and this is C. So ABC is a right angle triangle. So the velocity now, velocity of the body, as you know, it will be given by the slope or gradient of displacement time graph. Slope will be given by perpendicular by base. Tan theta means perpendicular by base. So perpendicular here is BC and the base is AC. Now the value of BC, if you look at this, the value of BC in this case is 40 minus 10 meter, because B is this point is 40, and C is this point is 10. So if you want to know this value, so it will be 40 minus 10. So that is equals to 30 meter. So again we have to find the value of AC. So this value of AC will be 4 minus 1. That is equals to 4 minus 1 is 3 seconds. So this side you have second, time is there, second. So C is 4 and this point corresponds to 1. So 4 minus 1 will give you 3 seconds. So in place of AC, in place of BC, I'll write 30 meter, and in place of AC, I'll write 3 seconds. So this will be equal to 10 meter per second. That is, the velocity of this body, which is moving, is 10 meter per second. This velocity is uniform. That means if we, instead of considering these 2 points, if we consider any other 2 points on this graph line, and if we calculate the slope of the graph line, then it will come out to be 10 meter per second, meaning that the velocity is uniform. The second one is, for the second data, if we plot the graph, then the graph will be like this. Because when the time is 0, in this case displacement is not 0. Here the displacement is 10. That means the body is 10 meter away from the observer initially. So that is why the graph will look like this. The displacement is increasing by equal amount in equal time interval. So that is why the body is moving with uniform velocity. And when the body moves with uniform velocity, its graph, displacement time graph, will be a straight line inclined to the time axis. If we have a body which is moving with variable speed in a fixed direction, that is with variable velocity, then for such kind of motion, the displacement time graph will be a curve. It will not be a straight line, but it will be a curve. Let's say at different times we have noted down the displacement of the body. When the time is 0, displacement is also 0. When the time is 2, displacement is 10 meter. When the time is 5 seconds, displacement is 30. And when the time is 6 seconds, displacement is 47. For this motion, if we plot a graph, the graph will look like this. So what you get here is a curve. So if you have a body moving with variable speed, you get a curve. So in order to calculate the velocity, which is in this case a variable velocity, that means the velocity at different point is different. So if you have to calculate the velocity at a particular instant of time, then that instantaneous velocity can be obtained. Like for example, if you want to calculate what is the velocity of this body at 5 seconds, then in order to calculate the velocity, at 5 seconds, here we draw a tangent. Now this tangent, from this we'll calculate the slope of this tangent, and this slope of this tangent will give us the instantaneous velocity at 5 seconds. So we complete a right angle triangle in this manner. Now the value of this right angle triangle, let's say this is ABC. If we calculate the slope, then we can calculate it like this. The velocity of the body will be given by the slope of ST graph, displacement time graph, and the slope in this case is perpendicular by base. Perpendicular is BC, slope means tan theta means perpendicular by base, and base is AC. Value of this BC is, this is B, this is exactly here at this point, so it is 47, and this is here at 10 minus 10, so that will give you 37 meter. And the value of this AC, so this is here at 7 and this A is here at 3, so how much you'll get? You'll get around 7 minus 3, that is equals to 4 seconds. So if you divide 47 meter, which is BC, by AC, which is 4 seconds, so you'll get the value of the variable velocity or instantaneous velocity at 5 seconds. So you can calculate this and obtain the velocity at 5 seconds. That will be the instantaneous velocity, as the body is moving with variable velocity, means at every point its velocity is changing, and at 5 seconds the instantaneous velocity of this body is 37 by 4 meter per second. The second type of graph is the velocity time graph or VT graph. In velocity time graph, velocity is plotted along the vertical axis and the time is plotted along the horizontal axis. If we consider a situation where a body is at rest with respect to an observer, at rest means its velocity is 0. So if we plot a graph for the body which is at rest, then its graph will be like this. The graph line and the time axis will overlap. As the time increases, velocity is not increasing, velocity is remaining 0 only, so the graph will be like this. This line itself will be the graph. The graph line overlaps the time axis. For a body which is moving with uniform velocity, that means constant velocity, the velocity time graph will be a straight line parallel to the time axis. We have velocities of the bodies at different time intervals, different times. When the time is 0, velocity is 10 meter per second. When the time is 2, velocity is again 10 meter per second. When the time is 4, velocity is 10 meter per second. It goes on like that. That means with the change in time, velocity is not changing. Body is moving with constant velocity of 10 meter per second. If we plot a graph of this kind of motion, then you get a straight line parallel to the time axis. When the time is 0, velocity is 10. When the time is 2, velocity is 10. When the time is 4, velocity is 10. So if you plot a graph, then the graph will be a straight line parallel to the time axis. This will be the graph. Velocity time graph will be a straight line parallel to the time axis when the body is moving with uniform velocity. From the velocity time graph, we can calculate velocity at any instant. For example, if you want to know the velocity at 1 second, then it can be calculated like this by dropping the perpendicular on the graph line. And again from here, you draw the perpendicular on the displacement on the velocity axis, so you get the velocity. So you can also calculate the acceleration. If you find the slope of the velocity time graph, then the slope of velocity time graph will give us acceleration. So acceleration in this case, if we calculate, that will be given by the slope. Slope means inclination. This graph line is not inclined to the time axis. It is parallel to the time axis. So slope will be 0, means that acceleration will be 0. Since the velocity is not changing with time, so acceleration is 0. You know acceleration means increase in velocity with time, but with time velocity is not increasing, it is remaining constant. So that is why acceleration is 0. And the slope of this BT graph is also 0. You can also calculate the displacement of the body after a certain instant time from the velocity time graph. So in order to calculate the displacement of the body, we have to calculate the area enclosed between the graph line and the time axis. So in this graph, if you want to know what is the displacement of the body after 4 seconds, for example, after 4 seconds, what is the displacement of the body? If we want to know, then what we have to do? We have to calculate this area enclosed between the graph line and the time axis. So since we are calculating the displacement of the body after 4 seconds, so we have to calculate this area. This area we have to calculate. You can clearly see this area is rectangular area. So the area of the rectangle is given by length into breadth. So from here to here is length. Length is 4 seconds. And the breadth from here to here is breadth. So it is 10 meter per second. 10 meter per second. So this side you have meter per second. So this is 10 meter per second and this is 4 seconds. So if you multiply these two, you will get 40 meter second and second gets cancelled. So you get 40 meter. So the displacement of this body after 4 seconds is 40 meter. Likewise, you can also calculate displacement after 2 seconds or displacement after 6 seconds by calculating the area enclosed between the graph line and the time axis. Suppose if we have a body moving with uniform acceleration, which means that its velocity is increasing by equal amount in equal time interval. Then for such a body, the velocity time graph or BT graph will be a straight line inclined to the time axis. We have different velocities in different time intervals. So when the time is 0, velocity is 0. When the time is 1, velocity is 10 meter per second. It goes on like this. So if we plot a graph for these points, then the graph will look like this. First one is 0. When the time is 0, velocity is also 0. So the first point will be here. Second one is when the time is 1 second, velocity is 10. When the time is 1 second, velocity is 10. Second point is here. If you join all these points, then you get a straight line passing through the origin and inclined to the time axis. So if you have a body moving with uniform acceleration, then in that case, the velocity time graph will be a straight line inclined to the time axis. So you can calculate the velocity at any instant by dropping the perpendicular. If you want to know the velocity of the body at 3.5 second, then in order to calculate that, you drop a perpendicular, you draw a line on the graph line from this point, then again from this point on the graph line you drop perpendicular on the velocity axis. So that way you can find the velocity at any instant of time. So at 3.5 second, the velocity is 35 meter per second. So this point is in between 30 and 40, so this point is 35. So at 3.5 second, the velocity of the body is 35 meter per second. In this case, as the velocity is increasing with time, you can clearly see with time the velocity is increasing. So there is an acceleration. So in order to calculate the acceleration from velocity time graph, we find the slope of the velocity time graph. So in order to calculate the slope or inclination or gradient, what we do on this graph line, we take any 2 points, let's say this point and this point, and complete a right angle triangle. This is A, B and C. ABC is the right angle triangle. Now we have to calculate the slope. Mathematically, slope means tan theta, tan of this angle. So tan theta means perpendicular by base. So slope of this BT graph will be perpendicular. Perpendicular is BC and base is AC. So the value of BC, if we calculate, BC means you will get 40. So point B corresponds to 40 meter per second and C corresponds to 10 meter per second. So you will get 40 minus 10, that is 30 meter per second. So 40 means from 0 to this one is 40. This line from here to here is 40. The value is 40 meter per second. And from here to here, the value is 10 meter per second. So you need to calculate only this much. So it will be 40 minus 10. That will give you 30 meter per second. So similarly, in order to calculate the value of AC, C corresponds to 4 second. So this will be 4 minus A corresponds to 1 second. So this will be 3 second. So the value of AC is 3 second. So BC is 30 meter per second. AC is 3 second. So you are getting as 10 meter per second square. This second goes in the denominator. Second into second gives you second square. So this is the acceleration of the body. And acceleration here is uniform. If we calculate the acceleration by taking any other 2 points, you will get the same value. We can also calculate the displacement of the body after a certain instant of time using velocity time graph. And as you know, the displacement is given by the area enclosed between the graph line and the time axis. We are trying to calculate the displacement of the body after 3 seconds. So in the graph, this is point 3, this is 3 seconds. So this area will calculate, this area. This area enclosed between the graph line, BT graph line and the time axis, this area will calculate. You can clearly see this area is a triangular area. So in order to calculate the area of this triangle, formula is half into base into height. Half into base. Base here is this value from here to here. Base is 3 second. Into height is this one from here to here, and height is 30. Height is 30 meter per second. Second and second gets cancelled. 2 and this 30 also get cancelled. So 2 15s are 30. So ultimately you are getting 15 into 3, that is equals to 45 meter. That means the displacement of the body after 3 seconds in this case is 45 meter.